So we've reached section 3.5, which is the last section for chapter 3. And in this section, we're going to talk about how we can use box plots to help us give a visual of what the basic summary or the I guess you can think of them as the highlights of a numerical distribution are. So without having to put all that data on a histogram or a dot plot, we're going to use what's called a box plot to look at specific numbers. And so the 5-number summary, let me start with that. So the 5-number summary is a description of the 4 quarters of the data, and it gives us 5 numbers. And so the 5 numbers that it includes are the minimum, and then followed by Q1, the median, I'm going to abbreviate, median, followed by Q3, and then the maximum. So every time you look at the 5-number summary, they should be in that order: the minimum, Q1, the median, Q3, and the maximum. And if we put these on a visual display, that's called a box plot. So a box plot is a visual display of the 5-number summary. So those 5 numbers. We're usually going to use StatCrunch to create the box plot, and we're going to analyze it, and we'll look at some images in a minute. So let's look at an example. The following table reports the average monthly high temperature for St. Augustine, Florida, compared to Mount Pleasant, Michigan. And so we've got the data for a year, it looks like January through December, of St. Augustine versus Mount Pleasant. So it says use StatCrunch to compute the 5-number summary and complete the table below. So it's somewhat difficult for me to get to StatCrunch using this software for the videos. So we'll talk about using StatCrunch and how to develop the box plot later. But the 5-number summary comes from those summary statistics. So that's summary statistics. Let me jot that down. Summary statistics option that we've actually probably seen. I know we've seen it before in StatCrunch. So let me just give you the numbers for now. So if I put all this data into StatCrunch and I did a column for St. Augustine and a column for Mount Pleasant, and I asked it for the 5-number summary from the summary statistics, or I would ask it for the summary stats, and I would write these down. The minimum for St. Augustine is 67. The Q1 is 71.5. The median is 80. Q3 is 87. And the maximum is 90. And then for Mount Pleasant, the minimum is going to be 29. The Q1, and by the way, StatCrunch is going to calculate these numbers for you. So this Q1, if you're wondering where I'm getting these numbers from, they're not in the table. StatCrunch would give those to me. So it's actually calculating the first quartile at 42.5. The median at 57.5. Q3, it's going to calculate at 75. And then the maximum is 83. So below is the box plot for Mount Pleasant and St. Augustine's monthly average high temperature. Label them for both cities. So St. Augustine is at the top. So here's what we have. The minimum temperature for St. Augustine, I'm marking it down here, is around 67, not around 67. And that corresponds to this, what's called the lower fence. And I'll explain this better in just a minute on the next page. But go with me for a second. So this is 67. Down here, and then Q1, the 71.5, is going to be right here at the edge of the box. So that's going to be Q1. The median is the line in the middle of the box. That's where the 80 is, and if you look on your paper, that corresponds to a temperature of 80. And then Q3 of 87 is going to correspond to this edge right here for the box. And then the maximum temperature is going to correspond to this upper whisker at 90 degrees. Okay, make a little bit of space here. And then let's look at Mount Pleasant. Let's look at the same numbers for Mount Pleasant. So the minimum of 29 degrees, you can see it's a little easier to see. That corresponds right here. There's your minimum. And I'm labeling it 29. Let me put the minimum instead. So we're going to put the minimum here. And then Q1 for Mount Pleasant was 42.5. So Q1, my graph might be a little bit off, or I'm questioning that 42.5 number, but either way, this is where the edge of this box is where Q1 would go. The median is 57.5. That looks about right for this line, so that's going to be our median for Mount Pleasant. And let me see if I can squeeze that in somewhere. Let's see. The median is right here for Mount Pleasant. And then Q3 corresponded to 75 degrees. That's going to be up here. So Q3 and Q1 are the edges of the box. That's your Q1 and your Q3. And then your maximum is up here at 83 degrees. What do you notice? So I've got a lot of stuff on here. I'm going to erase everything I have. You've got them labeled on your paper, so I'm going to go ahead and erase everything I have just so we can look at the graphs themselves. But what kinds of things do we notice? Well, hopefully you notice that the spread is much larger for Mount Pleasant. So the box itself, how far apart the box is. Remember what the IQR was in the last section. The IQR, remember, was the difference between Q3 and Q1. So if you're looking at a box plot, that's visually how wide is the box itself. So you can see that the spread for Mount Pleasant is a lot wider than the spread for St. Augustine. So we can say Mount Pleasant has a larger spread. You also could compare the medians of the two. You can say that St. Augustine has a higher median temperature than Mount Pleasant. So even if I didn't give you the numbers in the box above, the 5-number summary, if you had no knowledge of that and all you were looking at were the two box plots, you could see visually that the median for St. Augustine is certainly a good bit higher than the median for Mount Pleasant. Okay, so what else can we do with these box plots? So box plots do make it easy for us to see where the outliers are. And so the way we're going to look for outliers is we're going to find what are called the fences. The fences. So visually the fences, let me go back for just a second. The fences are the ends of these whiskers. So in high school, if you learn these, you might have called them box and whisker plots. They call these the whiskers because they go out. So the end of the whiskers, we're going to call those things, we're going to call the fences. So the fences give us a cutoff for what would be any values in the data set that are unusual. How do we compute the fences? Well, the lower fence we're going to say is Q1 minus 1.5 times whatever the IQR is. That's how we're going to calculate the lower fence. The upper fence, we're going to calculate Q3 plus 1.5 times whatever value the IQR is. So any values that are above the upper fence, greater than the upper fence, or lower than the lower fence are going to be considered outliers when working for a box plot. So the next example, it says find the upper and lower fences for the St. Augustine temperature recorded from the last example. Were there any outliers? So let's do that. Let's find the lower fence. So the lower fence, we're going to say is Q1 minus 1.5 times the IQR. Now before I get too into this, I do need to figure out what the IQR is. So the IQR, remember to calculate it, it's Q3 minus Q1. So I'm going to go back a page. So for St. Augustine, Q3 was 87, Q1 was 71.5. So we're going to do 87 minus 71.5. So for St. Augustine, the IQR was 15.5. Now let's use that in our calculation for our lower fence. So our lower fence is going to be Q1, which is 71.5, minus 1.5 times the IQR of 15.5. So get your calculator out and let's go ahead and figure out that number. Let's see, I'm doing this on my calculator. So I've got 71.5 minus, I believe if I'm doing my math right, I'm getting a lower fence value of 48.25. All right, let's compute the upper fence for St. Augustine. So the upper fence is going to be Q3, which is 87, plus 1.5 times the same IQR, 15.5, that we already calculated. So 1.5 times 15.5, let's see, plus the 87. I'm getting an upper fence of 110.25. Now, here's the deal with these fences. When you have the box plot, you're going to draw your fences. Let me go back to the previous picture for a second. You're going to draw your fences either to the minimum value or the lower fence, whichever you come to first. So for the lower fence for St. Augustine, we're getting a value of 48.25. Our minimum, however, was only 67. Do you see what I'm talking about? The minimum was 67. So when the StatCrunch created the box plot, it drew the lower fence to the minimum of 67. It didn't go all the way to this 48.25 number because there was no such temperature in our data. Our data didn't go past 67. So let's go back to the question. The question says, were there any outliers? And the answer for the lower fence, the answer is no. There were no outliers because the lowest temperature was 67. For this data to be an outlier, the temperature would have to be below that 48.25 lower fence number, and there weren't any. Same deal for the upper fence. You're going to draw your fence in your picture. You're going to draw that, or StatCrunch is going to draw it, either to the maximum or the upper fence, whichever it comes to first. Well, the upper fence by calculation is 110.25. What was the maximum temperature for St. Augustine? It was only 90. So your upper fence stopped at 90. The cutoff for unusual temperatures would be anything beyond 110.25. Well, did we have any temperatures for St. Augustine greater than 110.25? The answer is no. So no outliers for St. Augustine. So the next example, it says the first and third quartiles in the distribution of daily high temperatures in St. Augustine in 2000 are 73 and 86 degrees respectively. Using these values, what temperatures would be considered outliers for St. Augustine in that year? This should say outliers. So we're going to do the same thing. We're going to calculate the IQR and figure out what the upper and lower fence would be. And that's our cutoff for outliers. So the IQR, the first and third quartiles, so that's going to be Q3 minus Q1. So they gave us that. We have 86 minus 73. Let's see, and that gives me a value of 13. And so my lower fence is going to be the lower quartile, so that was 73 minus 1.5 times 13. So let me go ahead and compute that number, and let's see what we end up with here. 0.5 times 13, so 73. Let's see, I'm getting a value of 53.5. Check your math against mine, see if you get the same thing. So the lower fence would be 53.5. Now, I don't actually know what the minimum temperature is for the year 2000. That wasn't given to me. This is different data from what we were looking at previously. All I know is Q1 and Q3. So my lower fence would be 53.5. My upper fence is going to be 86 plus, so Q3 plus 1.5 times 13. And so let's see what that gives us. 105.5. So I don't actually have the data, but it says what would be considered outliers. So outliers in this set, outliers would be any temperature that's below 53.5 degrees or above the upper fence of 105.5 degrees. So if I had the data set, if I had any temperatures that were below 53.5 or above 105.5. So we've done this before, but using StatCrunch to find the 5-number summary, that's going to come from your summary stats menu. So you're going to go to stat, once you have the data in a column, stat, summary stats, select the column. And then to do a box plot, you're going to go to the graph menu, and then you're going to select box plot as your graph, and then select the column. And StatCrunch will set up the box plot for you. We won't ask you to do a whole lot of these by hand. I'm going to skip this next example because we don't have the data in front of us. We'll look at something like this in class. Let's go to the last page and let's look at the Chapter 3 quick review. So it says, the first question, it says, what is the most appropriate way to measure the center of a symmetric distribution? And that would be the mean. Most appropriate way to describe the variation in a symmetric distribution, that would be the standard deviation. How about the most appropriate way to describe the center for a skewed distribution? That's going to be the median. And the most appropriate way to describe variation for a skewed distribution, that's going to be the IQR. What can you say about the mean and the median of a symmetric distribution? So if you have a symmetric distribution, the mean and the median are both going to be right in the middle. So they're going to be about the same. Now, on the other hand, what can you say about the mean and the median of a right-skewed distribution? I would not memorize this rule. What I would do is make a quick sketch of it. So if we have a right-skewed distribution, it's going to look something like this. So think about when you calculate the mean or the true numerical average, what is that going to do if you've got a right-skewed distribution? So the mean, remember, is going to be pulled upwards by these people making a higher salary. So the mean is going to be higher. So the mean, when you have a right-skewed distribution, is going to be greater than the median. Like I said, the way I think about it is these people that are on the high end, think about it like salaries. They're going to pull the mean up. And the median would be better represented down here because it represents where more of the data lies. For the left skewed distribution, the opposite is going to be true. And again, if you need to draw a quick sketch, draw a quick sketch. So what happens with a left skewed distribution? Well, these lower ended values are going to pull the mean down. And so with a left skewed distribution, the mean is going to be less than the median. And if you need to, just make a quick sketch. What numbers are, or what measures are most resistant to outliers in a data set? Remember, that's going to be your median and your IQR, which is why we prefer those if the distribution is not symmetric. Below is a 5-number summary for a city's daily average temperature. Give the ranges of temperature that would be potential outliers based on the summary. So to find this out, we're going to be looking at where those upper and lower fences would be. First, we need the IQR. So the IQR is going to be 71 minus 54, right? Q3 minus Q1. So I'm getting an IQR of 17. So the lower fence is going to be 54 minus 1.5 times 17. So 54 times 1.5. So 1.5 times 17. I said that wrong. So let's see. I'm getting a value, if I've done my math right, of 28.5. For the upper fence, we're going to take the Q3 of 71, not 73, 71, and we're going to add 1.5 times the IQR. So 1.5 times 17 again, plus 71, gives me an upper fence of 96.5. So what would be considered outliers? Anything lower than 28.5 or anything higher than 96.5. So any temperature above 96.5 or below 28.5 would be considered an outlier in this particular data set.